These are your 4-4 notes on parallel and perpendicular lines. After yesterday's activity, we discovered some things about the slopes of parallel and perpendicular lines. So really quick, parallel lines. The symbol for parallel lines are those two slanted straight lines that go to the side that says parallel. And then the symbol for perpendicular is that upside down looking T. It looks like a right angle. So parallel lines are lines that will never intersect, and perpendicular lines are lines that will intersect. Lines can only intersect at one spot, but they will intersect at 90 degrees. So that's why they're perpendicular. When we discovered the slopes yesterday for parallel and perpendicular lines, we learned that parallel lines have the same slope, and perpendicular slopes have their slopes will multiply to give you -1. The product will be -1. A better way to say that, though, is it has a negative reciprocal. So opposite sign and flip the actual rise and run. In symbols, if you look at the picture below, we're saying that line AB is parallel to line CD. Okay, whenever we name lines, it's a good review for geometry. We just use 2 points on that line. And they're parallel. They have the same slope. If you count slope from point A to point B, that's down 1, down 2, and then over 1, 2, 3, 4, 5, 6. So I went down 2 over 6. That's a slope of 1/3, -1/3. And if I look at the slope from C to D, I go down 2 units and over 6 as well. So the slope of AB and the slope of CD are the same. They'll never touch because they're rising and running the same amount. They're chasing each other. When you look at the slopes of EF perpendicular to GH, to go from E to F, I'm going to go from F to E. So I'm going to count up. I'm going to go up 1, 2, 3, 4, 5, 6. So that's a positive 6. To the left, 1, 2, 3. So EF slope is equal to -6/3 or -2. So the perpendicular slope would flip the sign, so it should be positive, and it should be flip the 2 into a half. So when I look at the slope from G to H, I'm going to rise up 1, up 2, and over 1, 2, 3, 4. Oops, I'm sorry. I went up 3, and then over 6. I didn't go up quite high enough. So that's a positive 3/6, which is a positive 1/2. So notice the slope flipped the 2 and flipped the sign. So let's just work through these equations and figure out the slope of the actual line given, give the slope of a line that would be parallel to it, and then the slope of the line that would be perpendicular to it. So first, we got to locate the slope in the equation. This equation is written in slope-intercept form, so I can identify that 2 is this given slope here. So if the slope of the original line is 2, the line parallel to that will also have a slope of 2, and my perpendicular slope will flip the 2 to 1/2, take the reciprocal of 2, and then because it was positive in the original, now it's negative. If you look at the second equation, it also is in slope-intercept form, so -3/4 is my slope. The line parallel to this line would also have a -3/4 slope. A line perpendicular to this would flip it, so the slope perpendicular would be 4/3, and it would be positive because the original was negative. So when I say negative reciprocal, I want you to understand that means opposite reciprocal, or that's probably the best way to say that. This next line is in standard form, so I can't really look at standard form and see the slope, so I got to do a little bit of rearranging. So I'm going to subtract 2x from both sides. That leaves me with 3y is equal to -2x plus 6. Then I'm going to divide both sides by 3. And my line is y equals -2/3 x plus 2. So now I can see that the slope of this line was negative 2/3. So a line parallel to it would also have a slope of negative 2/3. And to be perpendicular to it, we take the reciprocal and take the opposite sign. The negative of negative 2/3 is positive 3/2. If you look at the last example, this is in point slope form. Y minus y equals m times x minus x. Okay, so I really don't care about all the x's and the y's. All I'm concerned about is that the m value sits in front of those parentheses, so that tells me that the slope of the given line is 3. That means the line parallel to it would also have a slope of 3, and perpendicular slope would be negative 1/3. So I'm hoping that helps drive home the idea of slope and parallel and perpendicular. So we're going to go ahead and write an equation just like we did before in slope-intercept form. So our output is going to be in slope-intercept form. And they're giving us a point that the line is going through, and they're telling us that they want it to be parallel to the graph of the given situation. And so then they want us to graph each line. So the line they're giving us, this y equals 2x plus 1, is what we have to be parallel to. So I'm going to graph that line. So I start at, it's in slope-intercept form, starts at the y-intercept of 1, and then I'm going to count slope up 2 over 1, or down 2, 1 to the left. And there's my original line. My new line has to go through the ordered pair negative 1, 4. So if I look at negative 1, positive 4, my new line has to go through there. Notice my original line doesn't go through there at all. That's fine. So we got to be parallel to that red line. Since the original line has a slope of 2, my parallel slope is also 2. So I'm going to use 2 and this point to write the equation of my line. And so when I write the equation, I have two choices. I can use slope-intercept form, y equals mx plus b. I could also use point slope form. That's just a choice at this point. So I'm going to use slope-intercept form here. I'm going to plug in negative 1 as my x value and 4 for my y value. So 4 is equal to 2 times negative 1 plus b. And we're just repeating what we did already. So it's just the same thing. It's just how they give us slope is a little bit different. They give us slope through another line. 4 is equal to negative 2 plus b. If I add 2 to both sides, I get 6 is equal to b. And so b is equal to 6. And when I do that, I'm not done. I still have to write the equation y equals 2x plus 6. So if you notice, the two equations both have a common slope, just different y-intercepts. So this one is going to hit at 6, and then I can count down 2 over 1 to the left, and you can see how they're parallel. So I really like the graphing because it gives a good visual of what's going on here. Second equation here. Okay, so we have the original line is this, which the original slope is equal to negative 4. So my parallel slope is also going to be negative 4. I plug in x is 0 and y is 4. I'm going to use point slope this time. Y minus y equals m times x minus x to figure it out. I'm going to plug in the y value is 4, so y minus 4. Slope is negative 4, and then x minus 0. When I distribute, y minus 4 is equal to negative 4x plus 0. And all I have to do now is just add 4 to both sides to get it moved over. So my equation, right out of room, y equals negative 4x plus 4. So I'm going to graph that line. It's my new line. Start at the y-intercept of 4 and go down 4. 1, 2, 3, 4 over 1. Oh, try to hit your points. And then the original line started at positive 5 and went down 4 over 1. Very close together. But because one crosses at 4 and one crosses at 5, they're still parallel. Now we're going to do the same thing using different equations, different order pairs for perpendicular. So they still want the output to be in slope-intercept form, but this time we want perpendicular. So I'm going to start off by graphing my original line. This is the original equation. Start off with a y-intercept of -4 and a slope of -1/2. So that's down 1, 2 to the right, or up 1, 2 to the left. So that's the original line they gave us. The original line, it has a slope of -1/2. So my perpendicular slope is going to flip the 1/2 into a 2 and flip the sign from negative to positive. So I can use either form over here. Y equals mx plus b, I'll use. Plug in x is -2, y is 3. So 3 is equal to 2 times -2 plus b. 3 equals -4 plus b. Add 4 to both sides. My b value is equal to 7. So my perpendicular line is y equals 2x plus 7. So to graph that, my 7 is way up here, kind of in my work. And I got to go up 2 over 1, so I'm going to go down 2, 1 to the left, down 2, 1 to the left. And you will see, as I keep going, these two lines are going to intersect at a nice 90-degree angle. So graphing is a nice way to check to see if you're doing it right. For the next problem, this is in standard form. So when the original problem's in standard form, I can't tell what the slope is, so I got to do some readjusting. So I got to get y by itself. So 3y is equal to -2x plus 4. I subtracted 2x from both sides. I'm going to divide everybody by 3. Y equals -2/3 x plus 4/3. Okay, not everything's always pretty. So 4/3 is 1 1/3. So that's just above 1 on the y-axis. So every time I go down 2, I'm going to go right above that mark. So when I go down 2, 1, 2, I'm still above -1 a little bit. Over 3. I'm just hovering above -1. Then down 2, over 3, and I'm just hovering above that -3 mark. So there's the original line. My new line with my new slope, if the original slope is -2/3, my perpendicular slope, flip it and flip the sign, is +3/2. So I can just use y equals mx plus b again if you choose. Sometimes that tends to be the priority, popular choice. 3 is equal to 3/2 times 2 plus b. Nice that the fraction goes away. 3 is equal to 3 plus b. Subtract 3, subtract 3, b is equal to 0. So this equation is y equals 3/2 x. The y-intercept actually is 0. It goes through 0, 0, goes up 3 over 2, up 3 over 2. And there is the graph that's perpendicular. And I just want to point out that point that they gave us, my line should go through it. So this ordered pair 2, 3 here shows up on my graph right there. There's lots of lines that are perpendicular to the red line, but only one of them goes through the point 2, 3. And in this case, -2, +3 is right here. So it goes through the point that they asked us it should go through, and it's also perpendicular to that line. The last part, we're going to determine if they're parallel, perpendicular, neither, what's going on here. So before we begin, I'm actually just going to label them with A's, B's, and C's. So when we're talking about them, we can talk in terms of equation A, B, or C. So we're in number 9, we're just comparing those 3. So number 9, this is in slope-intercept form. So the slope of the first line is -2. In the second equation, I need to do some adjusting. Y is equal to 1/2 x, so the slope is +1/2. And in this third line, I got to divide by 4, divide by 4, divide by 4, get y equals 1/2 x plus 1. So when I compare these, making my comparison, There are no other -2s, so nobody's parallel to A, but A is perpendicular to B, and A is perpendicular also to C, and B and C, I should write down C's slope, B and C are parallel. So B is parallel with C. There you go. So what I did is I put them all in slope-intercept form, identified the slope, and then compared. If you look at the second part, let's just call these D, E, and F, just so we don't make a mistake. Equation D has slope of 1/2. For equation E, I got to divide by 3, y equals 1/3 x, slope of 1/3. So there's nothing there. And F has a slope of -1/2. So since D has a slope of +1/2 and F has a slope of -1/2, they don't have anything in common. Neither of these, any of these are not the same or negative reciprocals. So all of them are neithers, right? There's absolutely no relationship for parallel or perpendicular. So your lesson summary, find it. There it goes. Determine the slope of the line that is A parallel to that line and then B perpendicular to that same line. Just got to find the slope. Based on that information, that line, y equals 2x minus 5, give me the parallel slope and the perpendicular slope. And then I want you to go through this whole problem perpendicular to that equation. So we have to go through this ordered pair, and we have to be perpendicular to that equation. You can use point slope, or you can use slope intercept to show your work. Good luck.